Week 4, Problem 3. The first part of this problem asks for the algebraic summation of the moments of the forces shown about point A. That's just basically saying add up the moments created by these forces about point A. So when we talk about being about the point, that means that that point is the pivot. So if we think about point A, maybe I'll use a blue pen for this. If we think about point A as the pivot, well, what's true about the 60-pound leftward force and the 30-pound downward force? Well, you could think about point A as being axial to those vectors, which means that they act directly through the point and the effective length of the moment arm is 0. So the summation of the moments of the forces around point A, we can just simply ignore these two vectors, this 30-pound and the 60-pound vector shown here. The vectors that are going to matter are this 40-pound vertical vector, and this 45-pound horizontal vector. Now, these are offset some distance. This is supposed to be some type of a square structure, but it really doesn't matter. We could think about this vertical vector acting directly on a lever arm that's perfectly in line with A. So the question is, what is the moment generated by this 40-pound vector? Well, remember that the moment equals the force times the length of the lever arm, or the length of the torque arm. So in this case, the moment equals 40 pounds times, and what's the distance? 15 feet. Well, 40 times 15 is 600, and the unit of a moment, pound feet. And if you think about the direction of this is clockwise, which by convention we would consider to be a negative moment. And the reason that it's the other way you could think of it as being negative is we would think about this 15 feet as being a negative number because it's to the left of A. So negative 600 pound-feet, and again, it's a clockwise moment, which we would consider negative by convention, which is, probably a little counterintuitive, but it was the way things ended up getting set up. Now, how about this 45-pound vector? Well, again, the moment of this vector equals the force, which is 45 pounds, times the length of the moment arm, which is 6 feet. So 6 times 45. Well, 6 times 40 is 240, and 6 times 5 is 30, so 270 pound-feet. Now, this moment, the force is to the right, and it's going to tend to create a counterclockwise rotation, and so it would be a positive number. So we have this counter-clockwise moment of 270 pounds. So what's the net moment, which I'll label M sub n for net moment, about A? Maybe I'll put a sub A. Net moment about A is equal to negative 600 plus 270, which equals negative 330 pound-feet, which agrees with the answer given in the answer key, 330 pound-feet. Now, about point B. So now this is going to be the pivot point. Well, again, this 40-pound vector we can just simply strike, and this 45-pound vector we can strike because they are axial to point B, so they have no effect. So now we're looking at the moments generated by the 60-pound and the 30-pound forces. So, moment, and I'll just denote this of 60 to indicate that it corresponds to the 60-pound vector, equals 60 pounds times, what's the moment arm about B? 6 feet. Which is going to equal 360 pound-feet. Now, let's think about the motion. the 60-pound vector is pulling to the left, so it's going to create counterclockwise motion. So that's going to remain a positive number. The moment created by the 30-pound vector equals 30 pounds times, what's the length of the lever arm? 15 feet, which equals 450 pound-feet. Now let's think about the direction of rotation. That's going to cause a clockwise rotation, which we would express as a negative number. So negative 450, and it's a clockwise moment. So the net moment about point B equals 360 pound-feet plus negative 450 pound-feet. 360 minus 450, that's negative 90 pound-feet. And again, that agrees with the answer given in the answer key.